Hi guys, welcome back to the shop. Today we're going to be calculating circuit load. We're going to see if we have enough available wattage left on a circuit that we can add some more lighting to light up the bench. And during this video we're also going to be showing two important steps that a lot of people make mistakes on when calculating this that can turn into a very dangerous problem. But before that, let's turn it over to the newsroom for a public service announcement. Yes, welcome back to the news desk. This is a public service announcement. Electricity is dangerous. Please be safe and observe all local laws, regulations, and building codes in your area. If you're not comfortable in taking on an electrical project yourself, please contact a local licensed electrician in your area. Thank you. Now back to your regular scheduled program. Alright guys, and that's very important, is to always be safe with electricity. It's invisible and it's extremely dangerous and it can kill you. So if you're not comfortable with these projects, please get a licensed electrician to help you with it. So let's go on into the step-by-step process. So how to calculate this is you're first going to look at what your circuit amps are. And to do that, you just look at the breaker, and it'll usually either be 15 or 20 amp breaker depending on the size of the wire that you're using. Here in America we're using 120 volts, and amps times volts equals the wattage. This is the limit, 2,400 watts total. But when power tools and things start up, they'll have a surge of electricity coming in, as well as just to keep a more safe buffer zone, you always want to reduce it to where it's 80% of the total. So we take 80%, which is 0.8, times 2,400 watts equals 1,920. That's the max amount we can do on this circuit. I went ahead and I calculated, or I looked up what all is on this circuit. 6 plug-ins. Kind of a standard rule of thumb for a house plug-in is 1.5 amps. And say that varies depending on what you're plugging in, but 6 times 1.5 times 120 equals 1,080 watts. Now the floodlight has 2 bulbs, and we looked at the actual, not the bulbs, but what is the fixture rated for. It's usually a little gold sticker and they'll say, max 65 watts. This one is 100 watts. So we have 2 bulbs at 100 watts equals 200 watts. So 1,280. But the difference here is we're in a shop and we're running some higher powered power tools. So what I did is I went and I wrote down some of the power tools that I use on these plug-ins. But we'll take this top one here, the hydraulic press. 13.5 amps times 120 means 1,620. That's how many watts it's pulling when it's turned on, which is a lot more than the 1,080. So what we need to do is take 1,620 plus the lights of 200 equals 1,820 watts. That's what's currently on the circuit. And as we looked over here, we figured 1,920 watts. So that means we have 100 watts left to safely add to that circuit and still be under that safe continuous load rating. So we're going to be looking for a 100 watt or less light fixture to be able to add it safely to that circuit. Now, what about those two dangerous mistakes I mentioned before? Well, the first one we kind of went over was on light fixtures, you do not go by what light bulb is in it, especially with LEDs and stuff now. Even though you could put like a 14 watt light bulb in, if the socket's rated for 100 watts, that's what you need to use. And the reason for that is if 5 years down the road that bulb burns out and you or someone else puts an incandescent in, you could then overload the circuit because now your numbers are a lot higher on wattage. The second deal is a lot of time people will, if their breaker's tripping because they're overloaded the circuit, they'll put in a bigger breaker size. They'll go from a 15 to a 20, and that is dangerous because wires, they come usually in a 14 or a 12 gauge, most common. You can get bigger, but they are only rated to carry so much electricity through them. So if you have 14 gauge wire, which is only rated up to 15 amp breaker, and you put a 20 amp breaker on there, you're running the risk of overheating these wires, which could then get hot and melt the casing around them, which they'll short out and spark and could cause a fire. Other thing, if you're wanting a more deeper dive into electricity, one of my favorite books and one that I still use today is the Black & Decker Complete Guide to Wiring. I'll leave a link down below, but I'm using the 5th edition. I think they're up to the 7th. But what's so great about this, it is full of pictures and diagrams, and that's one of the main things I do is the diagrams on how to wire in plugins and light switches together, and it gives very simple, easy to use instructions. It's a really good little handy thing to have on hand to reference back to when you're wiring up your shop. But that's all I got for today. If you have any questions, be sure to leave them down below in the comment section, and I'll catch you next time. Thanks. Bye.